Hi everyone, welcome back. Today we are going to learn about the how a single phase energy meter is working. So let's see the introduction about the single phase energy meter. And single phase energy meter, it is an integrated type instrument which is used to measure the energy which is utilized by the electrical load during the particular interval of time. This instrument can be used for both domestic as well as industrial purposes for the measurement of energy. And this meter is less expensive and it is very accurate for the measurement of energy. So this is the schematic diagram of an energy meter. We will see how it is constructed and how it is working one by one. So, about the construction of the single phase energy meter, it is classified into four main parts. One is nothing but driving system, and second one is moving system, and third one is braking system, and fourth one is the registering system. Okay. So, and the first one is nothing but driving system. So, in the driving system, here and single phase energy meter, it consists of two electromagnet. One is nothing but upper electromagnet, another one is nothing but a lower electromagnet. So the upper electromagnet is connected across this is nothing but phase and this is nothing but neutral. From the phase it will be taken into the coil, from this coil it goes to the neutral. So this is a load. So here this coil is connected, this upper electromagnet and this coil is connected across the source, or it may be called load. So that this upper electromagnet is called voltage coil, or it may be called as pressure coil, or it may be called as an pressure coil. And the second one, lower electromagnet. This lower electromagnet, this is phase and this is neutral. The lower electromagnet which is connected in series with the load. It is connected in series with load. So it is called an current coil, or it is called an series coil. Okay. So here an upper electromagnet, it consists of more number of turns and very thin wire, and the lower electromagnet, it consists of less number of turn and very thick wire. So from these two electromagnet which is driving the aluminum disc, so this is nothing but a driving system. So here the supply voltage which is exactly 90 degree. And the next one is moving system. So here when the power supply is there, the voltage coil or pressure coil is always getting energizing and it produces electromagnetic fluxes. It moves downwards. And if there is no load, the current coil not exciting, so it doesn't produce any flux. So the opposing flux is zero. So the aluminum disc will not rotate. If you are increasing the load, if you are putting any kind of load, so the current which is consumed by the load which is flowing through the lower electromagnet, or it will be called a current coil. So once if the current is entering through the current coil is getting energizing and it produces an electromagnetic flux. So from the voltage coil it produces some amount of flux, and from the current coil it produces some amount of flux. So in between these two flux there is an aluminum disc. So because of the phase shift of 90 degree between the two fluxes, while interacting the two fluxes, okay, it develops some amount of torque across the aluminum disc, and the aluminum disc gets rotating. The aluminum disc gets rotating. Once if the aluminum disc gets rotating, so this is nothing but a moving system, and this is a braking system. So if there is no load, so the voltage coil alone it produces flux, and from the current coil it doesn't produce any flux. So because of this voltage coil, the aluminum disc should not rotate. So that with the help of the braking system, we are attracting the aluminum disc under the no load condition. This is nothing but a braking system. And the registering system. So once because of the interaction of the upper voltage coil flux and the current coil flux, aluminum disc gets rotated. So if the disc is rotated, so the spindle and pointer which is connected with the aluminum disc is also gets rotated. So at the top of the aluminum, so at the top of the spindle, the register mechanism will be there. It reading, it counting the how much amount of energy which is consumed by the electrical rod, that will be recorded. That is an integrated type instrument. So this is the cross sectional view, and this is a current coil, and this is an voltage coil, this is a spindle, this is pointer, and this is electromagnet, and this is the aluminum disc. Okay, and this is the assessment for you all. So here, which of the following is an integrated type instrument, whether it's watt-hour meter, ammeter, voltmeter, or it may be a voltmeter. And the second one, and the series magnet of single phase energy meter, it consists of a coil with thin wire of few tons, thick wire of few tons, thick wire of more tons, thin wire of more tons. Put your answer in the comment section. And these are the few textbooks for this particular topic. Thank you.